All right, thanks for sticking with us. So as Liz mentioned, I'm Gabe LaHue. A lot of my work focuses on soil-plant water relationships and soil physical health. So I'm really excited to talk to you today about a project that is really at the nexus of soil physical health, soil moisture, and irrigation requirements for crops. So just to give a bit of brief background, why am I talking about irrigation requirements? So I think you all don't have to, I know I probably don't have to say this, but there's obviously a lot of competing demands for water resources in Northwest Washington. This figure is from the Skagit River Basin, but you can see, there's a lot of competition with municipal and domestic water rights, and this figure doesn't even include the minimum environmental flows. And so I know up here for folks on the Nooksack, there's a lot of scrutiny over how we're using water. So we really want to, make sure we're optimizing that water use. Climate change is projected to increase the demands on agricultural water use. This figure is again for the Skagit River Basin, but it's estimated, depending on the scenario, about a 10% increase in agricultural water use. But the other thing I want to point out is this is total agricultural water demand on the y-axis there. Look at the interannual variability compared to that projected change with climate change. The interannual variability is just huge. So you all already deal with a lot of variation between years in precipitation. And just to drive that home a little bit, this is now a figure from down in Mount Vernon, but this is growing season precipitation over the last 5 years. And in some years, we're getting double the amount of growing season precipitation as other years. So we really, one of the reasons we're focusing on irrigation requirements for this project is that, some of the growers came to us and wanted to have some of this work to really guide irrigation management, since trying to figure out how to adapt to that year-to-year variability. But I also mentioned that this project is looking at soil physical health. And so we mentioned in an earlier talk on the Mount Vernon long-term experiment how we had that road mapping session. And then I also showed this slide a bit earlier about those key soil health challenges, right? And a couple here that we're particularly concerned at with this project is that we know that degradation of soil structure or soil tilth from tillage and soil compaction can reduce our water holding capacity, which means there's less water available to the plants. We also might have to irrigate earlier, and it also restricts root growth, right? And so if you have a smaller root zone, you're drinking from a smaller cup, so you might be depleting that water faster. But we also know that soil-borne diseases are a big issue, and so both of those we'll be looking at as part of this project. So our research questions with this project, we had 4 different research questions, and the first one was around soil moisture thresholds for irrigation, and then the amount of water applied at each irrigation. Down in the Skagit River Basin, or in Skagit County, we're mostly dealing with overhead irrigation, so big gun, or in some case boom cart irrigation. So how does the amount of water done with that sprinkler irrigation affect potato yield, tuber size, and disease incidence? Does the timing and amount of irrigation affect skin set? So that's something we're also looking at, since that skin set has been a big issue for producers. Does soil compaction affect rooting depth, and therefore how quickly these irrigation thresholds are reached? And then lastly, as part of a little bit of a separate project, some producers down in Skagit County have asked us to look at alternative methods of irrigation. I already mentioned that folks are kind of living under a bit of a microscope, and there's a lot of scrutiny on agricultural water use. So having other options available to us and trying to think out in the future and test out some other alternatives. So we were looking at whether drip irrigation can maintain soil moisture, potato yield, and tuber size compared to sprinkler irrigation. So I'm not going to focus, the 2 questions I'm going to be focused on for the sake of this talk, just because I don't have a lot of time, are these soil moisture thresholds and the amount of water applied in compaction. How does that affect yield, tuber size, and disease incidence? And then looking at the drip irrigation, how that affects yield. So we tackled this with two different trials. And so stay with me here because there's a lot of different factors going on in these trials. But the first one is looking at irrigation scheduling and soil compaction and deep tillage. So our main plot for this is our irrigation treatments. We have 10 different irrigation treatments. We have both three thresholds for irrigation. So 75% of plant available water, 50% of plant available water, and 25%. Just as a refresher, plant available water is basically the water held between field capacity when all the water that's can be held against the force of gravity is drained off. So the kind of the maximum amount of water the soil can store, and permanent wilting point. So our threshold, those were our three thresholds, and then you can see kind of the soil matrix potential levels that correspond to those plant available water levels there. And those are just one measure of soil moisture. And then the second factor we varied was the amount of irrigation. So whether we applied a half an inch, 3/4 of an inch, or an inch. And those are pretty typical rates for growers down in Skagit County at each irrigation. And again, with sprinkler irrigation. And it was factorial. So we had each of these treatments at each like soil moisture threshold level. We had each of those irrigation amounts. And then lastly, we had a no irrigation control because unlike our previous speaker in Idaho, we can get away with that. We're just probably not going to optimize yield and quality, but it's really important for us to demonstrate the value of irrigation, especially as we do have more scrutiny on agricultural water use. So all these were irrigated with sprinklers. And then for figuring out when we met those thresholds of 75, 50, and 25% of plant available water, we used three different methods. We used two types of soil moisture sensors, two different measures of soil moisture, and then also a calculated water balance based on weather station data. And that was really important for us. I'd be happy to talk to anybody about that further if they'd like. But really, there's a lot of variability there. So being able to use those three approaches to triangulate, when two out of those indicated irrigation was necessary, that's when we irrigated, because there's a lot of variability. And just going off one of those approaches, in my opinion, can lead you a little bit astray. So those are the irrigation treatments. And then the second part of this trial was our compaction and deep tillage treatments. So each of these kind of strips where you see that red line there, these were divided in half. And so we had strips that were either compacted or not compacted. And what I mean by that is the compacted ones had field traffic and then the initial rototilling of the field pretty soon after a rain event. So it was not ridiculous. It was definitely a time where somebody could get on the field, but it was higher soil moisture than recommended. And then also, it wasn't chisel plowed right before the last rototilling event. So it had been chisel plowed, but not right before the last rototilling event. Whereas our uncompacted treatment was we waited a few days to rototill. So it was rototilled when soil moisture was lower. And it was chisel plowed immediately prior to the final pass with the rototiller. And then real briefly, I also wanted to mention the second trial we did where this was just looking at irrigation methods. So a bit simpler of an experiment, although not necessarily simple to implement. So we had our sprinkler irrigation, which is kind of our standard practice. We had, again, a no irrigation control. And then we had two drip irrigation treatments, both of which I'm calling subsurface drip irrigation here. One of those was a very shallow treatment, so it was almost surface drip, but basically it would, at planting, it would have been on top of the soil, but then after hilling, it's buried under the soil. So, just a couple inches, but on top of the seed potatoes and on top of most of the tubers. And the other one we had was a deep subsurface drip irrigation. So that was buried down at 16 inches. So getting it quite a bit down there. And this, we really wanted to see if this was feasible for a couple reasons. Some of you familiar with production in other areas, for example, in California, they do a lot of deep subsurface drip irrigation where they can leave it in place for quite a few years and do all their tillage activities over that. So like, for example, in processing tomatoes, have the drip at 12 to 14 inches and do a lot of their activities that drip in the ground 10 years, depending on gophers and what other rodent damage you might have. But there's also areas in, like, say, in Nebraska, there's been trials where that's been drip in the ground for decades. And the reason we wanted to test this is because, what we producers is, one, it would be very hard to pull that drip tape at the if you pull that drip tape out at the end of the season with the shallow treatment, you'd have to get your potatoes out right after so you don't get any greening. And that's happening at a time where there's just already a huge amount of crunch with harvest. And so that would be really hard for the producers to do. And two, the economics of it, there's not that many times producers irrigate each year, maybe 4 to 6 times a year down in Skagit County. And so is that actually going to be economically feasible to justify a drip system? Whereas with this deep system, if you maintain it well, potentially you could leave it installed for your rotational crops or even back to potatoes in 3 to 4 years. So all those were irrigated at 50% of plant available water on the same schedule as trial 1, same methods. And they were not irrigated the same amount. The irrigation methods were designed to achieve a target soil moisture. So let's go back to trial 1 and look at just those results. So this is what soil compaction looks like. So on the y-axis, you have your penetration resistance. So on your vertical axis there in pounds per square inch. And then on our x-axis, on our horizontal axis, you have the soil depth in inches. And people often use like 300 psi as a threshold that can start to limit root growth. But our compacted treatment is that one that you can clearly see that big rise in penetration resistance starting at about 9 inches, the rototiller depth, whereas that either the lack of that early rototilling or that later chisel plow, that got us a lot more rooting depth. And you might say, does that matter when our seed piece is at close to, pretty close to the soil surface? This is all soil surface prior to hilling. So does it really matter if we have deeper than 9 inches? And we're still working on our root data now, but we do see roots going down. We sampled all down to 2 feet, and we're still finding roots in those bottom sections. So yes, I would say our roots are affected by that. We're still working on how they're affected. So kind of first, we didn't really see any effects of any interaction between compaction and irrigation treatments. And so I'm just going to be looking at the effects of compaction and the effects of our irrigation treatment separately. But we did see that soil compaction without corresponding deep tillage reduced our total yield by 7% compared to no compaction and chisel plowing. On the irrigation scheduling side of things, so let me orient you to this graph. So again, this is our potato yield on the vertical axis, and then we have on the horizontal axis, we have our threshold treatments. That negative 72 is that 75% of plant available water. So that's our wettest treatment. And then that negative 444 is our 25% of plant available water. And that's our driest treatment, except for the no irrigation. And then our amounts of irrigation are on the top there. And we did not see an effect of the total amount of irrigation on yield, which is really interesting. That you could irrigating a ½ inch and an inch didn't change anything differently. That was kind of surprising to me, but that actually agrees with some farmer participatory research we did earlier with kind of half or double rates of irrigation with boom cart application that was fairly robust, and it showed a similar result there. But we do see that irrigating at 50% of plant available water or higher, so that negative 72 and that negative 167, these treatments, those had higher yield compared to our treatment that was at 25% of plant available water or our no irrigation. So no irrigation reduced yield by about 20%, and that the driest irrigation threshold reduced yield by about 14% compared to either of our 2 wetter thresholds. And I should mention that one of the reasons we're doing this work is, these thresholds really vary depending on your region. These irrigation thresholds in soil matrix potential, those are supposed to be kind of somewhat independent of soil type, but in practice that doesn't actually hold up. If I look at soil moisture thresholds for the Columbia Basin, those are all wetter than anything I'm presenting here except for my no irrigation treatment. So again, in theory, supposed to be translatable, but that doesn't really hold up for us. So it is really important to have work tailored to the region for this. So I mentioned we also looked at diseases. Really, we're collaborating with Dr. Chakradhar Mattupalli on this, and really we were focused on the surface blemish diseases since that's a big problem in our region. That data is still in progress since this is just the first year, but one thing we weren't expecting is we did see rot actually at harvest, and that's not something I've really seen in a lot of our potato trials before. I've done a lot of work with collaborating with plant pathologists over the last few years, and so I'm kind of embarrassed to just label this as total rot. But unfortunately, we don't know exactly the causal organisms of these, but this is, disintegrating rods that you would be called immediately and not put into storage. But we did see that the total weight of rotten potatoes increased with our wetter irrigation treatments. So specifically the one that was irrigated at 75% of plant available water had significantly more total ROP than the one that was irrigated at 25% of plant available water or the no irrigation treatment. So our sweet spot was kind of in that middle where we kind of still had a reasonably high yield, or like we didn't see a difference in yield with that one, but we did have that lower ROP. And again, we don't see an effect of the amount of irrigation, which again to me was kind of surprising because I would have expected maybe those higher irrigation events. That's something our producers have told us. When you're irrigating a full inch, maybe that's too much at one time, and that might be causing some anaerobic conditions right in the root zone, but we didn't see that effect. Shifting on real quick to trial 2. So this is now also looking at potato yield, our no irrigation treatment, our deep subsurface drip irrigation treatment, our shallow, and then our sprinkler. And we kind of see a gradient of responses there where the no irrigation treatment had a lower yield. It reduced yield by 18% compared to sprinkler irrigation, whereas we didn't see a statistically separable effect with our sprinkler versus our shallow or our deep subsurface drip irrigation, though this is something we're going to continue to monitor because even though it's not statistically separable, it could still be very meaningful for a grower. But I will point out that, this is something we're going to continue to work to optimize. We were honestly just, making sure we could get soil moisture up to, up to that root zone, up to that tuber when we have it buried at 16 inches. And so we were really able to do that in the first year. Similar to that soil would break apart easily with the deep subsurface drip irrigation and the no irrigation treatments, which I think is interesting if you think about, having to cart off all that soil to your packing shed and then when you're running your line and stuff. So I think that's something we'll continue to look at. Again, not something we're expecting, but just something we kind of had to roll with, but we did see a pretty clear effect there. So with that, I just want to briefly thank the funders for this, the WSDA Specialty Crop Block Grant Program. I want to thank the whole team that worked on this, Liz, Ed, Adam, Doug, also Em and Nancy. And then I want to thank our collaborators on this project, Dr. Mattupalli, Dr. Griffin, LaHue, Dr. Neely, and Suzette Galinato. And I'd be happy to take any questions. Yeah.
Yeah.
Since you were doing standard irrigation amounts at the ½ inch, 1 inch, starting at 50%, were you reaching field capacity or exceeding field capacity with maybe your 1 inch, or how did that factor in?
Yeah, so you're talking about for the first trial where we have the different irrigation amounts, right? Yeah, so I mean, it really kind of depends on the threshold treatment, right? Because those drier ones, without getting too much into the weeds, like there's theoretical field capacity, like if you were doing kind of your calculated water balance, the drier ones, the amount you're adding with an inch is such that you would not still get back up to that field capacity. Whereas at the wettest level with that inch, you would get back up to field capacity. In practice too, all those treatments are gonna, if you look at the soil moisture sensors, are gonna spike the soil moisture a bit, but in the drier threshold treatments, you're not getting back up to field capacity. So you're kind of like declining and then maintaining, versus at the wetter treatments, you're kind of staying up there. Does that kind of answer your question?
Yeah, so I guess, was there a relationship? I might be confusing your surface and subsurface irrigation.
Oh, sorry, this was just the one without the methods, but are you talking about the trial and the different irrigation methods?
Yeah, and so then how did that relate to the root rot?
Yeah, so that's a great question. So we, especially the shallow subsurface drip, you really quickly see the soil moisture spike in that one, where you're getting above field capacity basically to saturation. And so we really had to dial back our irrigation times. And that's kind of a little bit of a trial and error process, but we really had to dial back the amount of irrigation for both drip treatments. We dialed it back compared to our sprinkler irrigation. But especially for the shallow subsurface drip, we had to dial back the irrigation to be much less. So I would say in terms of the amount of irrigation, the sprinkler irrigation was the most, and then the subsurface drip the deep subsurface drip irrigation, and then the shallow subsurface drip irrigation. But yeah, great question.
Gabe, that
Yeah.
drip irrigation at 16 inches, is that about as shallow as you can go and still farm over the top?
That's what we were hoping for. You know, I mean, y'all can probably tell me a lot better. We wanted to make sure, because like our chisel was about 12 to 14 inches. So we thought then the idea is you could dig over it, still chisel over it
Yeah.
to undo kind of any compaction you did with the digger and still not mess up that drip irrigation. So that was what we were aiming for with that, but y'all probably know a lot better than me, you know, the depth you're working with your implements. Obviously, if you're subsoiling with the deep ripper, you know, you wouldn't want to go crosswise on that because you'd be getting deeper than that. But I mean, GPS guided tractors, you should be able to, you know, subsoil if you really wanted to or needed to.
And if it's close, how many years are you going to be able to sustain that? You know, that could be tough.
What'd you say?
If it's that close,
Yeah.
how many years could you sustain that and farm over the top of that? I mean, so the terrain will change just a little bit through time.
Yeah.
And
Yeah.
you're going to rip it out.
And I think we had to choose. So we left this tape in the ground, and the plan is we're going to keep monitoring it. You know, I mean, you know, we need to look at, you know, the implements, you know, can we get the equipment we want to get done? Also clogging, you know, can we really avoid clogging? You know, we're running products, line cleaners through and things like that to make sure we kind of maintain it as well. But we're also in a little bit of an artificial system because we're a research ground. So I think a commercial system, because you could have a buried main, which we don't have on ours, I think that could protect it better. But yeah, that's a great question. And I think honestly, you could play with the depth a little bit, you know, so if you needed to go down to 18 inches, I think the main thing was we wanted to make sure, okay, we can get water up even with the chisel plowing over it, even with, you know, and so we can get that water up.
There's
But
possibilities there.
Thanks, Matthew.
All right, thank you. With that, well, thanks, Gabe. And I think Molly's got a hat for you as well for all the speakers that were in this session today. Thank you, everyone, for staying. Pesticide credits are in the back. There's also a sheet, I think, running around. Remember, pink is WSDA, white is British Columbia. We do not have Oregon